Okay, I think I'm going to continue because I did just 1 hour and it's just exploit kit. So I will continue because if not, there won't be time. So I will make a short introduction about the PDF format, the PDF basics. So it's a bit slow to transition to the slide. So what we have normally in a PDF file, we have a header where we can see the version of the PDF file, the PDF format, I mean. Then you have like the body of the PDF that it's a sequence of objects. Then we have a cross-reference table that is like a table of content of the PDF that you have all these lines saying this object is in this offset and this other object is in this other offset. And then finally you have the trailer, and the trailer will tell you, for example, what's the first object that the PDF reader has to take a look. That's called the catalog, but I will talk about it, I think, a bit later. These objects, this sequence of objects, can be a number, can be an array, can be a dictionary also, but they can be also a special object for the PDF files that is called stream. And the streams contain a dictionary and also some kind of content between the tags stream and endstream. This content can be compressed, can be encoded with some filters. In this case, for example, is the AXI XDecode, so it's hexadecimal. Okay, but you can also put more filters. So you can compress with something and then use this other filter and this other filter. So you can do a change of filters. So this is also used in order to obfuscate the PDF files. We can reference an object inside a PDF object with his ID. So we can have the ID, the generation number, and then the letters of OBJ. And then we have the end tag, that is end object. We can reference every object doing, for example, in this case, kids. This page has just one page. This object is a pages object that it means that it contains all the objects, all the pages of the document. So in this case, it's just referencing one object, the 3OR. So object 3 is the only page of the document. It's like a referencing. You can reference inside an object, you can reference another object and change it. And there is the catalog, what I was talking before. The PDF has a root structure, tree structure, where the catalog is the root. So that's the first thing that the PDF readers are going to read. They will check the trailer to know what is the catalog object. Then they will check this object, and they will continue getting the rest, the other objects. Okay. If an object is not included in the downward path from the catalog, it doesn't exist for a PDF reader. Okay. So we have, that's also suspicious. For example, we have a PDF file, and we find that an object is part of being big or small. If it's just like isolated, it's not referenced from another object, that's suspicious, because normally the PDF reader wants to see all the objects and handle them. So that we will see an example later. So what we can do is just have a text editor here and take a look how it looks. Okay, I'm going to show, yes, I almost forgot about it. So what you will have in the package is a beta utils installer. That's some help scripts that I created some time ago. I didn't check if it really works, but normally there are some distributions already with PyLibemu and PyV8. So that shouldn't be a problem. Then we have the SploitKits folder where I was before, with all the scripts, all the sample SploitKits page examples. And then we have the PDFs with analysis, with all the exercises, and the obfuscation with just also some examples. So that's all. I'm saying this because someone was asking me if I could explain like the structure of the package. Okay. What I wanted to do is go in here. I will use this. So this will be the header, and then we have the body with 3 objects in this case, and for each object in the cross-reference table we have a line, and then in the trailer we have this root, that it means that the catalog object is the object number 1 that is here, and here we can see the pages object, and here what I was commenting before. So that's what you can see normally with just an editor. If we have binary code or binary bytes inside the PDF, then we cannot see it with just an editor. So we need some tools like PDF. Also, I forgot to mention that the cross-reference table, this thing where you can have one line per object saying this object is in this offset, it's not really necessary for a PDF reader. So some of the PDF exploits just remove them, or they don't include a good information. So if you see, for example, a PDF file without a cross-reference table, it will work with PDF Reader, with Adobe Reader, for example, but you can see that's suspicious because normally they should contain this cross-reference table. Okay. So to analyze the PDF files, I use the tool that I wrote some time ago. That's called PDF. It's a Python tool with a command line. You have an interactive console, as you have seen before, with a lot of commands, with colors also. And this tool is included in Remnux. It was included in Backtrack, and now it's in Kali Linux. So these are all the commands that we can see that I will explain later. So you can execute the. I'm going to explain also later, but you can execute the tool like with the command, with a batch command that I showed you to beautify the code of the exploit kits, and you can use it as interactive, that is -i, and you can use it like basic, just to have a summary of a PDF file, a summary analysis. It contains. You can also use the XML output. And I know that it's a bit old, so I will try to include a JSON output in the next months. So you can incorporate that with another tool and do some kind of automatic thing. I'm trying to maintain this tool when I have time, so it's out of work hours, so sometimes it's difficult. But I try to upload changes, and a good thing of the tool is that I created an update command, so in every moment you can do update and try to get the last changes. So you don't have to go for another package, you just have the basic and you do -u and you update the tool. So that's also good. It includes JavaScript emulation, Shellcode emulation with PyLibemu, JavaScript analysis with PyV8, and it can check the object streams objects that are compressed inside the PDF file. It can check strings with parameters in the filters. That it's something that you can use also to obfuscate the files. So it contains a lot of things. Also, it supports encryption. So it's really nice. So here, for example, when I changed from SpiderMonkey to, I was using before SpiderMonkey for the JavaScript engine, and I changed to PyV8. And just because, let me check, maybe you can see here. So this was the execution with SpiderMonkey, and this was the execution with PyV8. So for some reasons, it's more harmful to use PyV8 because I can obtain the JavaScript better, and I can beautify, and also in the engine itself, it's, for me at least, it works better, the PyV8. Okay, I also included a virus total check, so you can check the hash there. You can check just the hash. You are not uploading anything to virus total. So if you have like a apt PDF file, you can still use this command because you are not sending anything. Well, you are sending the hash, but I think virus total is not checking every hash that it's searched. So what I'm going to do is just, here you have in the presentation some commands, but because I'm going to do it practical, I'm going to go for each of these commands. Okay. One important thing is that you can use PDF as a library also, not just as a tool. You can use the PDF core module to create your own scripts. So in this case, for example, this guy, Brandon Dixon, wrote a tool to extract easily the flash. Well, it's a tool, it's a script that is using my PDF core, you can see there, and just scanning the objects for the, well, you cannot see here, but it was checking just the header of the streams. So if it's like SWF or compressed flash, then it was extracting them. Quite basic. Okay, so I think I'm going to start already with this, because if not, I will run out of time. I will use this version, the same that you have there. Okay. So now, PDFs, analysis. So this is what I was mentioning about a simple execution. I'm not adding any command, so it's just showing the information about the file. In this case, it's a really simple and empty object. But you can see already the information that the tool is giving. It's giving the hashes, the size, the version of the PDF format, the number of objects that you can see, the IDs of these objects, which is the catalog of the document. That will be important later. So you can see this easily. You can also execute, well, if you have not seen before, but I will do first, the interactive console. So you have the same information at the beginning, but you can use the help command to see all the commands that you can use. For example, some of the basic commands are offsets. So you will see the physical structure of the PDF file. So you have the header, and in the offset 9, you have object 1, and this is the size. This is also important to check if there are really big files, and also if there are, for example, between this and this, there are just three bytes, 3 characters, that probably there are some spaces or some new lines, and that's not really interesting. But if you see like a huge gap here, huge space, it means that there is something there that maybe the exploit is using, probably a payload or something like that. Also, I have an example about that. The tree command, then you can see the physical, no, not physical, but the logical structure of the document. So you can have here, you can see here the, whoa. Okay, I hope you are hearing me before. This is the catalog, and this is the root of the structure, of the tree structure. And then you can see, for example, all the objects that are in the downward path. So that's what I was saying. If you see here another object, that's suspicious. Okay. I think before I go on, I was already mentioned this a bit, but there are some things, suspicious elements that the tool is showing. That it's, for example, the triggers. When you open a document, you can trigger some actions, and you can do that with the open action element. You can do that with the AA element, that's additional action element, and also with the action. But you can execute also, for example, JavaScript code with other elements using this acroform or the names. So all these things are like highlighted as suspicious when you are analyzing a PDF file. So you can see, maybe I should take a look at this. Okay. It will show also known vulnerabilities, and I'm trying to add some improvements about the detection of this to avoid false positives. Okay, if it's a PDF file that includes encryption and it doesn't have the a custom password, that's normally really suspicious. Because so about encryption, I will tell you later. No, I'm telling you now. Okay. So in the PDF format, you can say this is encrypted, but I'm not supplying a password. So that's empty password. And what it does really is, so you have a padding of, I think, 32 bytes. And if the password is empty, then the password is the padding. And if you add something, then the padding is less bytes. So there is like a default password there. So you can just encrypt the PDF file, send it, and it's encrypted. And when you open it with the Adobe Reader, it won't say anything. It will just decrypt automatically, because it's checking first the default password. So this is really good for obfuscate things. If you put bytecode there, malicious JavaScript code, you can obfuscate it with this. And with some tools that are not supporting encryption, that can be a problem. Also, for this is what I was mentioning: gaps in the offsets, big objects, characteristic strings. This for antivirus is really harmful. If a base exploit has, for example, a date with hour and seconds, some metadata, you can use that like a signature to detect them, of course. Okay, so I will continue with the practical part. So I have some offsets, 3. With the info command, you can see again the same summary. With the object command, you can take a look at the objects. And then you can have also raw object, that in this case, it will show the same because you are not seeing any, it's not encrypted, it's not compressed, it's not a stream. But this is useful, for example, with these filters that you have seen before with some hexadecimal characters. With object, you will see the content after decoding, after compressing, after decryption. And with the raw object file, raw object command, or you have also stream and raw stream, you will see that before all these things, before encryption, before decoding. So you can have the two views, just in case you need it. For example, if the stream is not decoding correctly, it will give an error, but you can still see that in the raw stream. That's an example. So we can create a command commands file, and we can put here some basic commands. And this is the other way to execute the tool, like in a batch mode. Put commands, and it's executing the commands and just stopping. Okay. So there are like these three modes. Okay. So we're going to do to the next one. This is a simple file, just executing JavaScript code, just for you to see how you can see that in here. And you can see, okay, there's JavaScript code in object 4. I'm going to execute this like this. And then in object 4, you can see the hello world. Okay, that's the normal execution. You can have some errors. And then it won't work by default because it's saying, okay, I'm detecting this error. I cannot follow with analysis. But you can use the -F to force to continue and ignore the error, and you will see the error here always. And it's exactly the same. And another way of execute it, we have this. Oh. I don't know why. So here, this is malformed. Why? Because there is a tag to start the object, but there's no end of object tag here, just here. So the tool is thinking that this is just one object. And because of that, it's just showing one object. But we can do another kind of parsing and just not look for the end of object tag. And that's with the -L. So I always execute the PDF files with this, with -fill. So now you can see 4 of them. Okay. This is also important, I think, or at least good to know. You can, in the PDF files, you can have updates. So you can create one PDF file and then modify one object, one thing, and it will contain the old code, also the original code. So in this case, for example, you have the hello world here, but you can see that there are 2 versions. So in object 4, if you execute the command like this, object 4, it's always getting the latest version. But if you specify the version that you want to see, it's object 4 in the version 0. So you will see hidden text. And you can save the first version. Save first version, KK, shit, remember? And probably it will be here. And you will see here the hidden text. So this is a good way to extract old versions, maybe to find a content that you don't want to publish, or something that someone has published, the government, and it's hidden there, or something like that. This is funny too. So this was like some years ago when you could use the launch. You have different actions in a that you can execute in a PDF file. You used to be able to launch a command from the system, from the PDF file, and you can say why. I don't know, because from the perspective of the security, it's not really useful, and also it's really bad. But we could do that some years ago. So someone wrote this PDF file, included an executable, and just dropping it to the system and starting it. So this is the sample, the third exercise. And you can see, for example, so this is what I was mentioning before. If the information is blue, it's just informative information. If the information is like this is yellow, orange, or a mix of it, it's suspicious. So you have to take a look at this. Sometimes maybe it's just a false positive, but it's good for you to take a look. So in this case, for example, this is the catalog object, and you can see, okay, there's one action here. What is that? And also the 13 object, you can see also here. So you already know that there is something that is executing. It's executing JavaScript code. So you can take a look at the object, and you can see here export object, blah, blah, blah. This is to export an embedded file to the system. Probably it won't work anymore because I think it's not really secure. So what we can do is, for example, what is this? Sorry. You can use the search command to search things inside the PDF file. Okay, so it says, okay, in the version 1, you can see this this string in these objects. So you can take a look. Also, you can see here, this is a launch object. It's a launch command. So what we can do is take a look at this. And what it's saying here is, if it exists this file, go to that directory. If it exists that file in this directory, go to that directory. If it exists, go to this directory, and then start it. So it is starting a PDF file that I have exported before. But is that a PDF file? That's the question. So we can check in the embedded files. We can go to object 9. We can use the references command to see references inside an object and references to an object. So you can do, for example, references to object 10, it's 9. You are seeing this here. And references in object 9 will be, say, 10. So this is sometimes useful when you want to go like backwards, when you see JavaScript and you want to know if it is executed or not. Like in this case, for example, we are seeing JavaScript code in object 13, and we can do references to object 13. That's object 8, and that was the catalog that I was mentioning before. So we know for sure that it's been executed. So we have this, we have this, this. Whoop, okay. So that doesn't look like a PDF file. So what we can do is easily extract. For example, I want to extract the stream from object 12, and I want to store it in a file. So the extraction of the files or of information from the PDF file, we can do it with this like normal bash redirection. We can use also like this to append to a file. We can use $ and the redirection to redirect to a variable, and we can also use this. Okay. So what we can do, for example, we're going to do two things. I'm going to extract this to a variable, PDF, for example, and I want to extract it also to the to this. So as usual, I don't know. So it looks like this is not a PDF file. So that was what it was doing, extracting the file, PDF file to on disk, and then try to execute it. And we have this also in this variable, and we can use, if I have internet, we can use this with a variable, btcheck, with this. And in theory, yeah, I have internet. So this is Zeus file, okay? But it's nice because you can store information in variables and then use this to continue with the analysis. You can maybe at some point you want to analyze obfuscated JavaScript and you don't want to use external tools, so you can do everything inside the tool. Okay, this is really easy. Here we are seeing the JavaScript code, and we are seeing also potential vulnerability in Object 12. So Object 12 contains JavaScript code, and we can use the command jas code to solve this code. Okay, we can see here the potential vulnerability and all these things. By default, with the JS analysis command, it is going to try to execute this JavaScript code. And if it finds an escape function, it will try to get the content of the argument. Sometimes it's not possible, but in this case, it is. So we can do JS analyze object 12. And we have here, again, the JavaScript code, and we have the shellcode. And the shellcode, we can, again, store it in a variable, and then use the sctest command. That's for emulate the shellcode. That's pylibemu. So you have to have installed pylibemu. And you can use sctest variable sh, and it will emulate the shellcode. Okay, you can see here it's getting the addresses of some functions, winsec, exithread, urlmon. And the funny thing the good thing of pylibemu is that it will try to download also the exe if it finds it. So all automatically. That is good. In this case, it's not finding anything because the domains are already offline, of course. So that was an easy one. All is working. If you see this, and you have not done anything wrong, then send me the error, please. In this case, it's just an error. Okay, so this is exactly the same as before, but containing a different JavaScript code. The JavaScript code here is this. But if we do exactly the same thing as before, try to analyze it, we won't get anything really. It's just showing the original code, but it's not doing anything. And why? It's because yes, code 12. Fact. So you see here, Kate is highlighting the function. It's just a function. So it's normal that it's not doing anything because it's just a definition of a function, but it's not called the function. So what you can do is say, for example, okay, so I know this function is here, but I don't know if it's called and where. So I can search again and say, okay, I have this in these objects. Object 1, is the catalog, and we can see here the open action. So when you open the document, it's going to be executed, this. So now, because we already have in the context of the JavaScript engine, we have already that function defined. You can see that with JS bars. With JS bars, you execute something, and you can have access to the JavaScript variables from there. So you see that it's in the context. So you can use just JS analyzed code, and then you can hear your own code, new script, and it will execute the function for you. This is another shellcode. So we do exactly the same as before. We extract it to a variable. We do like this. And again, we are trying to download something from a executable, and we will later execute it. So in this case, it was not all automatic, but we have to do also some things, some analysis things, some manual things. So here is the same. Here we have 3 objects containing JavaScript code, and if we take a look at that, this will be pretty huge. This will be smaller, and this will be okay. This is telling me. So we have detected automatically, because automatically what it does, PDF, is if there are 3 different snippets of code, JavaScript code, it will put it all together and execute it. Because in this case, for example, it's really useful. And you can say, okay, I want to see all. And it's not the same. So you can have here all the things, and you can have the array. So, but if you analyze it independently, or even if I think if you do like this, it says there is an error because the str is not defined. So you can say, okay, what is str? And str, besides a part of the 36, it's here in 35. Sorry. With JS code, it will beautify also the code, so it's always useful and it's better. So this is the str, and str depends on ARR, but ARR is not here. It's in object 34. So first you have to execute 34, then you have to execute 35, and then you have to execute 36 to have all in the context of the JavaScript engine. So we can do like analyze object 34, then object 35, then object 36, and then you have the next level. Also, what we can do, for example, is so this is escaping the bytes. We can store this in a variable, for example, my JS, and then do some replacements. We have the replace command, and we can do some basic replacements that is really handy, I think. For example, replace variable my JS, and I want to, because this is not really useful, I want this to disappear. So I have all in one line. So what I can do is I want to replace this with nothing. My JS replace okay, because with the JS analyze, if you do this, if you redirect the output, you will redirect the shellcode. In this case, there's no shellcode. I mean, there is shellcode, but it's not automatically extracted. So what we can do really It's a JS code, no, 36, and it will extract it to a variable called my.js. And I want just the last one. And now I'm doing the replacement. That should work. I'm showing the variable with the command show. And I see here this. And we can work with this. We can just copy this and use the JS and escape command. No, first we're going to create a variable, set like escape it, and then we paste it, and we have that variable there. And now with this variable, we use the JS and escape command. And we have the shellcode now. We can do exactly the same as before. Put it in a variable and use the lctest command to execute it, to emulate it. Okay, and you can see the different functions called. So this was a bit different. The catalog. This is a challenge from the Honeynet project. They put this PDF file and said, okay, analyze it and send me the results. And it was funny because there was like a trap, because here you can see easily, okay, in object 5 there's JavaScript code, so there should be there everything. So we can take a look at the JS code for object 5. And we can see here, okay, there are something related to annotations. This will be the eval code. Here is getting the annotations of the page 0, the first page. And here is getting the title. When you see something like this info title, the info object is the metadata object. And you can see this here also. The info object is the 11. So if we check object 11, this was referencing to info title. And in this object, we have something that is title. And we have object 10, which is referencing the object 10 there. So we have something here, and it will do something with this. Okay? It's getting that content and storing this here. So after analyzing this part, you can have a shellcode. But that was not the real shellcode. Why? Because if you take a look with the tree command, you can see two catalogs in the file. This was the object 5 that you can spot easily, and this is a vulnerability. That's okay. But the object 5 is in the downward path of the catalog with ID 1. However, the real catalog is the 27, sorry, the 27. So it's not going to execute that JavaScript file. So we have to take a look at what is here. Okay, and if we take a look again, we can see that there is an acroform there. So we can take a look at that catalog. This is normally used to execute JavaScript code. So we can take a look. This is also really typical for executing, put in the XFA form. So we can check the object 21, and we can see here a lot of shit. So we can extract this object. In fact, we can extract just the stream. It was 21? 20. So we should have it here. Okay. All right, 21. Yeah, I was. So, yep. It's a bit slow, but you can see here that it's an image, TIFF image, and this is base 64 code. So what we can do is just have that base 64 chunk and then try to decode it with the tool. So what I'm going to do is image. Next. It's really slow. It's because this is really huge, but even. I think it's not doing anything. Okay. I'm trying to remove all the thing if it. Ooh. So I want to exactly remove getting with just obtain the base 64 code, but it's because it's really huge in memory. I think it's doing it really slow. So I think now to work on this. Okay, this is going to be easier. Okay, now if I have done this well, it should be here, base 64 code. What I can do is use the decode command with the file and store it. No, and using base 64. Now we have here a shellcode. Well, we have here some kind of content with a lot of 19s. That's NOP, SLEP. So we can store it and we can execute it. And this was the real malware. So this was the solution, not the other one. Okay. This is what I was mentioning before. About if you find something that is not the downward path of the catalog, for example, in this case, this is suspicious. Okay, if you do this, it's like, this is huge. Okay, but this is related to this vulnerability. We have JavaScript code here, so we can take a look, and it's just heap spraying, and it's redirecting to page number 2. If we take a look at the pages, that should be. So there are 3 pages, and we have to go to page number 2, but 2 is counting like the 0 of the first page, so it should be this one. And here we find a reference to object 10 that is the vulnerability. But we're going to take a look at this lonely stream. And this, in theory, it's a stream. But if we do like this, there's nothing in the stream. So we can take a look with raw stream. And whoop. In theory, it should be encoded with flight decode, but normally it starts with an X here, but this is not an X, so this is not flight decode. This is something else. And you can see like M8 with this here, a lot of 12s, so probably it's XOR with 12, and this looks like maybe like a binary. So what we can do is say, okay, maybe this is a binary. What I'm going to do is do an XOR brute forcing against this raw stream 12, and I'm going to look for something that it's 16, sorry, that you normally see in binaries. This program cannot be run, blah, blah, blah. It's doing the brute force with this stream. Okay, and it's finding that with the key 12, you can see something. You can see that program string. So what you can do is, again, raw stream 16, and the key it's 12, and you can store it here. So it's the EM, the M is missing, but the rest is okay. So this is really a binary. This was the payload of this exploit. Oh, yeah. Starting Flash is easy also. You can search for just the SWF, and you can see, okay, in version 1, we have these two objects referencing SWF. If you take a look like this, it will show you, there are 4 versions. It will show you the object 26 of the latest version, but you want the version 1. So it's like this. And this is okay. 41, and this is a Flash file. You can take a look with just the stream. 2 in version 1, or just redirecting to Flash. Here you can use Flash dissector with oops. So this is working. So it's extracting correctly the Flash. Okay. This is funny because this is a loop inside the. Automatically, what it does, PDF, is analyze the JavaScript emulating it. In this case, there is a loop with some kind of heap spraying, and it's not going to finish. So what we can use is the -m. Going to kill it, and we can use the -m thing in order to not analyze automatically the JavaScript code. So you can see the JavaScript code here, and you can extract it, and you can remove the part where it is the problematic thing. So all this here, there are like loops, big loops, so we can remove it just to continue with the analysis. I think until here is okay. And we can try to analyze it now. File, and we get this new code. And with this, we will do exactly the same. I set into a variable, and with GAs and escape of my variable, I will get the shellcode again. So I think now it's okay. This is really nice also. We have here this nice JavaScript code, and because of that, we can extract it. This is, well, in fact, sorry, I want to extract it, but the original one, because if not, I will have some problems. Not the beautified version. If not, it won't work. So I want to remove all this thing. I'm not sure if I have something here. That's okay. So this is encoding called GS encode, just like this, I think. And I added a command to try to decode this, because you cannot see anything there really. So you can use the JJ decode, JJ encode is called. So you can do JS JJ decode, file, my file, and just should work. So you have the thing here, and again you have the shellcode. So you can do exactly the same as before, but I'm not going to do it because I think it's already a bit late. I will do so this was about analyzing. Okay, besides the receiving PDF exploits with exploit kits, I also was receiving this kind of emails. So just putting the PDF exploit there. For me, it was really funny because I didn't see it before. It's not really targeted or nothing like that. It's just distributing this, and it was dropping like Zeus peer-to-peer that it was taken down some months ago. So you can also receive exploits with email. Okay. For obfuscation, I will give just some hints. If you want to obfuscate your exploit that you have created with metaexploit or something like that, you can remove all the characteristic strings, all the metadata. If you are using, for example, JavaScript code inside a string object, you can encode it with octal encoding. If you use hexal encoding, probably you will be detected really easily, because I think Didier Stevens was including that to obfuscate the PDF files, but then Metasploit did it too. So all the antivirus companies added that as a signature. Okay, so it's better use the octal encoding. If you are using a string to store the JavaScript code, the malicious JavaScript code, then you can use filters and chain it together, use parameters, compress it, encrypt it, malform it. So I want to do a quick test with this out obfuscation. It should be, and that's the last thing, and finish. I wanted to show also this, but I don't have time, that it was the PDF that I received. So I will use this. Okay, you can. So I have not mentioned really a lot of commands to modify the PDF file, but you have also some commands to modify the strings, the filters, and also to create a PDF file. So in this case, we can create a PDF file with open action and executing was API alert like hi, and I save it like hi, for example. It should be probably here. Let's check if it works. So it's showing hi. Okay, so this is really basic. Now what I can do is encrypt it. So first, let's take a look at the hi. This will be the API alert. In fact, you could see it here. No, here. That's what we have. Okay, I go again and do. Sorry. I will open the hi and just do encrypt. Easy. And save it as enc.pdf. If I execute it, it says secured because it's encrypted. But it's with the default password, so it's not asking for a password. It's executing the same thing. If you take a look with the editor this time, you see something more weird, but that's encrypted. If it's a huge malicious JavaScript code, for example, you can hide it easily. Also, now you have an encryption PDF file. What you can do is create a simple one with simple create PDF simple and save it as good PDF. It's not doing anything really. But the good thing is that you can use this good file, you can use every PDF that you want in order to embed the malicious one. Okay? So we can do embed -x. The -x will be to execute the malicious PDF file embedded in the good one. Okay? And we have to say we want to embed our encrypted file here. And we want to save it. Embed. So we should see here when we execute it, instead of seeing the good one, okay, I think it's doing something, or I don't know what it's doing. Because, okay. No. I will. I think with this is okay. If I execute the PDF file, well, I don't know why it's not working right now. I cannot even close it. Well, you have to believe me, if you do these scripts at home, you will see it correctly. And this, in fact, you can see there in the bottom, you can see enc PDF secure. So we have executed the embedded, and it's opening the encrypted one. Okay, so that's one way that you could use to obfuscate the code. And now I can not use anymore the slides. But I will try to. So it's just the last one. So whoop. Just thank you to some people that helped me to to get some exploit kits, some PDF exploits. Thanks to Angelo Delaira that helped me with this is the creator of PyLibEmu. And when I find a shellcode that is not running, I said, hey, Angelo, it's not working. Can you help me? And normally, if he has time, he's really good guy and he does it. Of course, Black Hat for let me come here. The Arsenal, because I started presenting PDF like some years ago in the Arsenal. It was a really good opportunity. And yeah, in general, the Fox IT, the research community, that is really nice. Okay, thank you very much for attending. And if you have some questions, probably we can do it later because probably they are waiting for me already. And I have here. Also, you give me good feedback, I will give you a T-shirt. Now that's not good. I have some T-shirts here, not too much, just like 5, 6 in different sizes. So if you want one, I will just leave it here. Independently of the feedback, you can put me right there. Okay, thank you very much.